Hello students, hope all of you are fine. Today it will be a doubt clearing class. Okay, so some students have asked me, sir, in bisection method, where to stop? Where to stop our iteration process? So today in this video I will try to give you two wayouts. Okay, so let's see. So bisection method, where to stop? To get a root of fx of a function of an equation fx is equal to 0, and you have been asked to correct up to m significant figures, or they can ask correct up to m decimal places. They can ask both the way. What you need to do is go to an arbitrary step, say pth. Okay, then you will get a corresponding x value at that point, at that iteration point. So I am suggesting you to proceed one step further. Okay, that means I am asking you to go to do this p plus 1th iteration process, and now compare the two values of x. Compare these two values of x. Okay, now if these two values of x have the same digits up to this m significant points, significant figures, or m decimal places, stop there. No need to go further. Okay, stop iterate process there only. Fine. Another way is, see, basically your starting interval is a to b, right? A to b. A to b, and what you are doing, this is your a to b, this is the gap, and you are trying to reach here. Okay, what you need the process is, by the method of midpoints, we are calculating the midpoints, and we are just moving closer to your root point. Fine. So basically, if I am standing at nth iteration step, that means you have divided that interval, this interval, into n steps, into n times. You have divided this gap n number of times. That means for iteration number 1, the gap is this one. Okay, you have chopped your range. In the next step, you have chopped 2 times because this will be included, right? So 2 square. Again, in the third step, this will be included, and here also it will be one more time you will chop your interval. Like that way, for the nth iteration number, you will be chopping up to b minus a to the power n term. Okay, so after this is basically will give you the value of x between 2 successive steps. Fine, so this much you have chopped down. You have narrowed down your range. You have narrowed down your range this much, by this much. Fine, so I can write, suppose this is the error limit, error tolerance they have given, is epsilon. Okay, epsilon I can write it as 10 to the power minus m. What is the m? M decimal places. Okay, or significant figures. Okay, if you can map with the absolute error term, absolute error restriction, we have done in the module 1, right? So here it should be 0.5 into 10 to the power minus m, right? For absolute error, my limit was the 0.5 into 10 to the minus m, but I have neglected that 0.5. Mainly I am focusing on how many digits are 0. This is basically giving how many digits are 0, right? How many digits are becoming 0. So basically this is this one. That means I can write this error tolerance by this, and this gives basically the relation, the value of x between 2 successive steps. Okay, so from the question you will get this m, right? This m you will directly get from the question. If it is not given at the question, then it is on your hand. You can play with this. B minus a, you will be selecting B and A in the first step. Okay, so we will be starting with B and A. So this is already Fine. Then how long you need to proceed? So see, if this is my nth iteration step, right? So if I solve this, if I put this here and this one, I keep it as it is, then if I take the log, okay, to get the value of n, to get an expression for n, so I will get this much. So I'll get this much. So when you are selecting B and A in your first step, and if you can map with the this m significant figures what they have given in the question, then directly you can predict how long I need to proceed. Okay, then you can predict that I need to go up to this much step, this much of iteration, this number of iteration process I need to perform. Fine. So see, if you choose B and A such that the difference is 1, then if my epsilon is this 10 to the minus 2, that means 2 it will be given in the question. Okay, if not, it is on your hand. Then you will find that n to be 7. That means you need to go up to, then you need to perform 7 iteration process to get your result. Fine. So similarly, if it is 10 to the minus 3, you need to go up to 3 more steps. That means 10. For 10 to the minus 4, it is 14. Likewise. So now if you sir, you can ask me, sir, if I choose v minus 2 be something else, say 0.1. Yes, no problem. You can put this, whatever you have chosen, put this b minus a here. Okay, put the difference value here and you will get the corresponding n. Fine. And this will, again I am telling, this one will be given in your question. That means up to which decimal, which places you need to correct. Okay, if not, then you can play with that. Fine. So in this way you can predict how long I need to proceed. Or you can say there is another way of writing is find the function value at each points, right? Suppose I am reaching at the n plus 1 step and just calculate the function value. If that function value is very, very close to this one, that means or it crossed this limit, that means this one, it is already given in the question, I hope, m. Okay, then you can stop there only. So you can proceed in this way also. Okay, but this will give your exact iteration, how much iteration you need to perform. Okay, this will give you a way, and you can do this also directly. Okay, so in every step you are calculating the function values, right? And you check with this. If it cross this point, this number, then you can stop. Fine. So basically this is on user's hand. So in this way I have shown you some way out. I have given you some way outs to predict where to stop for bisection method. So this part is over. Another query was, sir, in Newton-Raphson method, my question was this one, right? So I told you to put this one as the cube root of 24 and your function value is this one. Okay. What you need to do here is, I told you I have put x is equal to 3. Now somebody has asked me, sir, why have you put x is equal to 3? See, if I put x is equal to 3, that means it is 3 cube, right? That means 27 minus 24. How much is the difference? It's 3. Okay. Now say if instead of 3 I put 2. Okay. So it will be 2 cube, right? 8 minus 24, that is minus 16, right? Now we need to find out the root. That means I need to find out a value of x such that this function value goes to 0. So which one is near to 0? This 3 or minus 16? Obviously 3 is near to 0. Okay, so 3 is near to 0, right? Minus 16 is far away from 0. So you can choose x is equal to 3. So sir, you can ask, sir, can I put x is equal to 2.5? Yeah, you can do that also, but check whether it is near to 0 or not. Okay, I told you, I've given you an simple way how to study is that since we know that cube root of 27 is 3 and 27 is very close to 24. So I have directly taken x is equal to 3 in that class. Okay. But basically you can proceed in this way or you can proceed in the conventional way also. That means both x is on your hand. More you choose x to closer to your root, it will be more easier to solve. Since we don't know what will be my root, right? You don't know. So try to fit. That means you need to make trial and error method. Fine. Then you will get an way how to solve, how to take the initial point. Fine. Suppose instead of cube root of 24, they ask 20. Suppose square root of 27. Okay, or square root of 23. Then we know the square root of 25 is 5, right? So 25 is more closer to 23 or 27. So you can choose x to be 5. If you want, if you can put, sir, instead of 5, I want to take 4. Yes, you can do that also. You can put 4, but you see this function difference will be that time. In that case will be much more for 4 because 4 squared is 16, right? So 23 is very far away from 16. Okay. Or 27 is very far away from 16. Fine. So basically this is on your hand and be little clever in choosing this value. Fine. So this are the two queries mainly student have asked. So I have tried to give you a way out. Okay. Stay safe. Thank you very much.